Right, okay guys, so this is the Alkenes, which is leading directly from the Kraken video. So if you've not watched the Kraken video before this one, then make sure you do that. It kind of tells us where the alkenes are coming from and how they slightly differ from the alkanes. So the stuff we're going to talk about in this video is National 4 and National 5, but mainly National 4 because the National 5 alkene stuff is very similar to what we have done with the alkanes, naming the branched alkanes and all that sort of thing. I think you'll find this stuff pretty straightforward because quite a lot of it is very similar to what we spoke about previously with the alkanes. So let's have a look. So similar to what we were doing for the alkanes, you need to talk about the general formula. It is slightly different for the alkenes. You need to be able to name them, you need to be able to write chemical formula up to and including 8 carbon atoms, so same for the alkanes as well. Draw the structural formula, and we'll talk a wee bit about this term unsaturated as well. So let's see. So in the previous video we kind of touched on the fact that the alkenes contain a carbon-to-carbon double bond. So the alkenes are a set of compounds, so they're a homologous series that are different. So they've got the same or this kind of similar chemical properties to the other alkene family members, and they all follow the same pattern, kind of similar to the way the alkanes do as well. So the main thing you need to remember is the presence of that double bond. So we'll look at that in more detail whenever we're looking at the full structural formula. So the reason that this is quite important, so we spoke about Kraken and why we kind of break down larger hydrocarbons into shorter ones that are more useful. So one of the kind of uses of the products of Kraken is turning alkenes into plastics and other things as well. So plastics is the kind of main one, obviously due to the fact that we do use plastics for quite a lot of stuff in industry and all that sort of thing. So the reason for that is because of our double bond, but we'll look at that a wee bit later whenever we look at how the alkenes react with different things. But for today we're just looking at naming, structure, all the kind of basic stuff. So similar to the alkanes, what you've actually got are the same prefixes for your alkenes as well. So we're starting off with 2 carbons, so there's not an alkene that only has 1 carbon in it because you need to have that double bond in there. So we can't have a double bond unless there's at least 2 carbon atoms. Okay, so the first member is ethene, then we've got propene, butene, pentene, hexene, heptene, and octene. Okay, so the main difference between naming the alkenes is your ending. Okay, so that ends in ene rather than ane. Okay, so just a wee reminder, a couple of ways that you can remember some of your prefixes. Pentagons, 5 sides. Okay, so obviously pent would be 5 carbons. Hexagon, 6 sides, so hexene, 6 carbons, and then the obvious one is your octopus, which has 8 legs. Octene, 8 carbons. Okay, so again you can pause, take a wee note of naming your alkenes. So, full structural formula, very similar again to your alkane, so let's just have a wee look at how we would do that. So we'll go for ethene just to keep it simple. I think we'll do a couple of examples just so that you can see. So again, just drawing that double bond in there. It's kind of like an equal sign, but just making sure you've got your 2 lines in there to show your double bond. And you've got your hydrogen atoms round about each carbon. So again, I mentioned this in the Kraken video, make sure you've always got the 4 bonds coming out of each carbon atom, because remember the valency of carbon is 4, it has to make 4 bonds. Okay, so that double bond actually counts as 2, right? So you can see 1, 2, 3, 4 bonds. So just a reminder, your wee single lines are obviously just your single bonds as well. So if we go for, say, butene, right? So we've got 4 carbons, pop your double bond in, and then again just be very careful with the number of hydrogens you're putting round. So wherever your double bond is, you're always going to have 1 less carbon one less hydrogen on your carbons, okay, because you can only ever make 4 bonds. A lot of people fall into the trap and they still put the same number of hydrogens round about as if they were drawing an alkane. So if I was to put a hydrogen in here, that is completely wrong. Okay, so just be very, very careful with that. So you can practice drawing those on the next slide. So that is your butene. So you may be wondering at this stage, can the double bond go between different carbons? The answer is yes, but we'll touch on that in the next video, right? So we're not going to kind of spend too long on that. I just want to briefly mention that just now. So for the purpose of this and for the purpose of the kind of National 4 stuff, if you just pop your double bond on your N2 carbons, just to keep it simple just now, because there are a couple of rules with the double bonds being in different places. Okay, so full structural formula, that is basically it. It's exactly the same aside from your double bond. So this table, if you want to make sure you've got a note of this in your jotter somewhere, so similar to what you would have done for the alkanes, just so that you can clearly see everything related to the alkenes. Okay, so I've filled in a part of that already, the one that we've just done. So you need to know your number of carbons, the name, the chemical formula, the full structural formula as well. Again, you need to be able to draw shortened structural formula for the alkenes, but again, we'll come back to that and maybe do like a lesson on full structural formula because it differs depending on what homologous series you're looking at. Okay, so we'll do that a wee bit later. So if you want to pause, take a copy of that and we'll quickly go through the answers in a few minutes whenever you're ready to unpause, okay? Right, so similar to the first slide, I'll just pop in these names for you. Chemical formula, again, you could probably actually draw these out first and then go back and do the chemical formula if you're wanting to like count your number of carbons and your number of hydrogens. If you're on the ball, you might actually have worked out what the general formula is and you might actually be able to work out the chemical formula off the top of your head. If you're in that position, brilliant. If not, we'll talk about the general formula in a second. Okay, so what I'm going to do here, I'm just going to draw these out and then we can work out the chemical formula. So again, always just making sure you've not got too many hydrogens on there. Okay, so butene. So this is probably going to get very messy very quickly as I run out of space. Right, so I just paused that video just so that you don't need to watch me drawing all that out, but check your answers, just make sure you've got the right number of carbons, make sure you've not got too many hydrogens in there. As I said, that's where people get trapped up. So we'll just very quickly do our chemical formula. So for propene, we've got 3 carbons, and if you want to count 1, 2, 3, 4, 5, 6 hydrogens in there. C4, 1, 2, 3, 4, 5, 6, 7, 8. And again, if you're seeing this pattern emerging, you might be able to do it without looking. So we've got C5, H10, C6, H12, C7, H14, and C8, H16. So actually it's probably easier to work out the general formula for the alkenes compared to the alkanes. So make sure you've got all of that, and if you were missing anything, then make sure you fill that in. So, general formula. So if we kind of look at our chemical formula, see if we can work out the pattern. CN, H2N, right? So nice and simple compared to the alkane. So again, just all that means is that N can be any number at all. So we're only really interested in carbons 2 to 8, so only up to octane. But maybe a problem solving question could be getting you to work out for any number of carbon atoms. So if we've got n equals 8, you're just doubling your number of hydrogens, which is 16. Okay, so if it was C 100, H would be 200, which is just double your number of carbons. Okay, so that's something to remember, so please make sure you take a note of that in some way, shape or form. Okay. So the kind of last bit of this for the moment, we're going to do a bit more on this later. There is an experiment related to this that you need to know about, but for the moment, if you're just familiar with the terms, then that's absolutely fine. So we spoke about this already, but this is kind of putting a label on it, if you like. So the difference between the alkanes and alkenes, so the alkenes are unsaturated. So basically all that means is it's got a carbon-to-carbon double bond. Okay, so alkanes are what we call saturated, so it means they've only got single bonds and nothing else, right? So the easy way to remember it, and the way I still remember it if I forget it from time to time, is that saturated begins with an S, so does single bond. Okay, so it's a bit daft, but saturated, single bond. Okay, so if you want to just keep kind of saying that over and over again, make sure you get it around the right way as well. Again, in the exam and kind of tests and stuff like that, this does come up. Make sure you get the alkanes and alkenes around the right way. Okay, so if you want to take a wee note of that as well, that's all there is to that for the moment. So that is it for the kind of basic alkene stuff. Like I said, we're going to take it a bit further a bit later when we're looking at branched alkenes. It does get a wee bit complicated, but that is it for just now. Okay, so writing general formula, naming, writing chemical formula, drawn and unsaturated. Okay, so if there's any issues with that, please let me know.